Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. In this video, we're going to look at 6 examples of input processing output programs in Python. If you've learned about the input and print statements, data types, variables, and basic math operations in Python, these examples are perfect for you. If you want to learn along with this channel, this video is in the Learn Python Programming Full Course playlist. All of the example programs in this video can be downloaded from my GitHub repository. There's a link in the description. Examples can be helpful when learning to program, but what's really going to accelerate your learning is writing programs yourself. So for each example, I'm going to tell you the problem, and then I'm going to suggest you pause the video and try to write the solution yourself. If you don't have Python installed, well, you should, but you can also write each program by following the code check links in the description of the video. And when you click the code check button after writing the code, your program will be run on test data. This will give you a good idea of whether you've solved it correctly or not. I'll then show you my solution, and as a final bonus, for the first 3 programs, I'm going to show you some context, a larger program that uses the code we've written, as well as web APIs, graphical user interfaces, and visual interactive programs as part of the solutions. I know it's hard when you're learning to program to see how the simple programs we start with fit into the larger software development picture. So I'm hoping this will offer some fun and motivating context, even if it doesn't completely make sense at this time. Stay with me on this channel and it will. Let's jump in. Program 1, calculating how much food our donation of US dollars can purchase in Ukraine. This program is based on an interview I heard with an aid organization that collects donations and then purchases goods to donate in Ukraine, putting money into the Ukrainian economy and helping those who have suffered because of the war. Write a program that obtains the US dollar donation amount, the exchange rate, and the cost of bread in Ukrainian hryvnia. Calculate the donation amount in hryvnia using the USD to UAH exchange rate, and give the amount of bread that can be purchased. I've put an example of how the program should look running in the docstring at the top of the program so you can work some problems by hand to help you understand the problem before trying to program it. For a donation of $100, an exchange rate of 47.29, and an average cost of bread of 32.71 hryvnia, the donation can purchase 144.6 loaves of bread. Bear in mind, of course, that an aid organization will be able to buy food in bulk for less money. Pause the video and write the program in idle, or use the code check linked in the description. How did you do? Here is my solution to the problem, called USD_UAH_exchange_solved.py. Your solution might be slightly different. I begin by annotating the variables in the program. Annotations are documentation. They mean nothing to Python, but they mean a great deal to other programmers. Knowing the type of a variable tells another programmer what can be stored in the variable and what operations are allowed on the variable. I have 5 variables, and they're all floats, because all of these quantities could have decimal parts. I have donation_USD, exchange_rate, and cost_bread for the inputs, and donation_UAH for a temporary result, the amount of the donation in hryvnia, and then loaves_bread for the final result, the number of loaves of bread that can be purchased with the donation. I decided not to round that down to an integer, although it's unlikely you'd be able to purchase a fraction of a loaf of bread. The first executable code is the input part of this input processing output program. I obtain the inputs from the user with input statements, converting each result to a float and storing it in the appropriate variable. For example, donation_USD equals float input how much is being donated, USD $. Notice that the $sign is part of the prompt. A person entering a numeric value can't put $signs or commas in their input because Python wouldn't then be able to convert that input to a number. But we can put a $sign in the prompt to make it clearer to the user they're entering a dollar amount. Once we have the inputs, we can process them into outputs. The first line of processing converts the donation from US dollars to Ukrainian hryvnia with donation_UAH equals donation_USD times exchange_rate. To calculate the number of loaves those hryvnia can purchase, I divide donation_UAH by the variable cost bread and assign the result into loaves_bread. That is the value that we want to output, so the final line of code is a print statement. I used the string format method of creating an output string, partly because it's very similar to how we format strings in Java, so Java string formatting is less of a shock to my Java students who have already learned Python. You might have learned or might prefer F strings, but hopefully you can see this is really quite similar. I've written with a donation of $, open curly brace, colon, 0.2F, close curly brace. You can buy open curly brace, colon, 0.1F, close curly brace loaves of bread, and then dot format, and in parentheses, donation underscore USD and loaves underscore bread. These are the values being substituted into the string format expressions in order. I've included a commented out version of the output with an F string below for comparison. Let's run the program and put in some typical values. At the prompts, I'll enter 100, 47.29, and 32.71. And I'm told with a donation of $100, I can buy 144.6 loaves of bread. When we're learning to program, we often begin with input processing output programs that get inputs from the user in the console and then display the results in the console. But in your experience, I'll bet you've rarely used a console program. You use a graphical user interface, and some data or choices come from you, but other data comes from websites or databases. For us to enter the USD to UAH exchange rate, we have to look it up, and the same for the price of a loaf of bread in Kyiv. But a more realistic approach would be to get those values from a trusted source. In this version of the program, called USD UAH Exchange Web API.py, I'm getting the USD to UAH exchange rate from a website called exchangeratesAPI.io. API stands for Application Programming Interface, and it's essentially a way for one program to communicate with another. In this case, we're using a set of commands provided by that website to automatically get up-to-date exchange rate data. Often, you'll need to sign up for an API service to use it. Many APIs allow for a certain number of free requests per month, and after that, you may need to pay a fee. When you sign up, you're given a unique code called an API key, which you include in your requests to identify yourself and access the data. You can see that the end of this program is the same as our IPO program. The difference is I'm getting the exchange rate and the cost of bread from two different websites with APIs that allow web requests, rather than prompting the user for them. The only value I'm prompting the user for is the amount of the donation. The program uses the requests library. You'll need to install that library if you want to run this program. At the top of the program, after the annotations, I'm constructing a URL, which is a request for the information I want. I include my API key and the value I want. Every API is going to be different, so you have to read the documentation. I got this URL and format directly from the documentation on the Exchange Rates API website. I then extract the exchange value out of the result I get back from the request. The result is in a dictionary format. A dictionary is a data structure in Python that you will learn about if you continue to watch the videos in this playlist. So understanding this code fully isn't far away. If there was an error with the request, I'm just setting the result to a hard-coded value that was correct on the day I wrote this program. I'm doing essentially the same thing to get the price of bread from a website called numbeo.com. And again, I have an API key from the site, and I got the code from the documentation on the website. When I run this program, if I put in $100 for the donation, I get back the amount of bread I can purchase based on today's exchange rate and bread cost, 143.7 loaves of bread. Program 2, converting a letter from lowercase to uppercase. This is such a common operation that most programming languages have a built-in way to do this, but knowing how it works under the hood will help you when you have to do something a little more custom. Plus, it's pretty cool. So the spec is to write a program that obtains a single lowercase letter from the user and returns an uppercase version of the letter. Nearly every character that is used for communication on this planet has a unique Unicode number assigned to it. For example, uppercase A has the decimal number 65 assigned to it, and B is 66, C is 67, etc. The uppercase letters are all in order. Then there are some other characters, and the lowercase letters begin at 97. They are also all in order. In Python, you can find the unique number for a letter or other character using the ord function. I'll type ord A in the console window. Python responds with 97. You can convert back to the character representation with the chr function, so I'll type char97. And I get lowercase a. To convert between lower and uppercase, you'll want to use the numeric value of the character you've gotten from the user and shift it by the correct amount so that you have the Unicode value of the uppercase equivalent. So, for example, you would shift 97 to 65 to convert lowercase a to uppercase a, and shift 98 to 66 to convert lowercase b to uppercase b, etc. Then convert it back to a string with char. Note that the difference between lowercase letters and their uppercase equivalent is always the same. Pause the video and write the program in idle or use the code check in the description. How did you do? Let's take a look at my solution called capitalized letter solved.py. I started my program with a constant called case shift. That's the amount that we'll have to add to the lowercase letter to get the equivalent uppercase letter. You might have done something like this, or you might have calculated that by hand and used the literal value 32 or negative 32, the difference between 97 and 65. I like the calculation because it is showing us exactly what case shift is, the difference between uppercase A and lowercase a, and the direction. It has a sign. I also prefer to use named constants, like case shift, to magic numbers, like 32. If I saw that number in a program, I might think it was the temperature for freezing in degrees Fahrenheit. A well-named constant makes code much more readable. We then have some variables for the letters and the numeric version of the letter. Then we jump into the input part of the program, obtaining the lowercase letter from the user with an input statement. Because this will be a string, and the input function returns a string, we don't cast that input to any data type. Our processing follows inputs. Our processing is our conversion code. I convert the letter input by the user to its numeric value using ORD, and I add the case shift constant to it. So that looks like ORD, open paren lowercase letter, close paren, plus case shift. Note that I'm taking the ORD of the string, then adding the case shift constant to it. I then assign that into the variable numeric letter. Now, if you used the absolute difference, 32, you'd subtract the case shift value. The lowercase letters have higher ordinal values than the uppercase letters. But I calculated the difference with the sign, so it's going to add negative 32. I then convert that new value, stored in numeric letter, back to a string with uppercase letter equals char, open paren, numeric letter, close paren. And finally, I print the result. Again, I'm using a format statement, but I've included an f-string version of the print statement below. Formatting here is quite simple because we're not doing anything special with the uppercase letter. So I just have curly braces to interpolate the uppercase letter value into. Now, for context, one example would be a game like Wordle. This is a version of Wordle that I wrote for this channel. I wanted to be able to add and remove letters in any order from my guess, unlike the real Wordle game. Notice that when I type a guess, I'm always seeing uppercase letters in the boxes. This is quite complicated because it's a full Wordle game, although I'll say that for a game, it's extremely simple. But it's much more complicated than what I want to show you for context. You can find this code in my GitHub repository, and I've got a couple of videos on how I developed it. But let's look at a much simpler program that simply allows the user to put letters in boxes. This is called capitalized letter GUI.py, and I'll run it. You can see what I'm typing appears as uppercase letters in the boxes. And if we look at the code, we can see this is creating an interface using PySimpleGUI. I have some videos in which I go into detail on how to use this library to create a graphical user interface. You will need to install the PySimpleGUI library if you want to run this program. Starting on line 37, we have what is called an event loop. This is the way a program with a GUI finds out what the user has typed or when they've moved the mouse or interacted with the program in some other way. And down on line 56, I'm taking the character that the user has typed and converting it to an uppercase letter using the same formula I used in the console program. Here I've put the converting to a number, adding, and converting back to a string all in one line. Program 3, averaging colors. This is a really simple concept that can have a big impact in a program. RGBA colors are represented as a red value, a green value, a blue value, and an alpha, or transparency value. Each value is an integer between 0 and 255. We're going to focus only on the RGB values. For our program, we're going to average 2 colors. We'll ask the user for the red, green, and blue components of the first color, and then the red, green, and blue components of the second color. We'll then average the red components, the green components, and the blue components, arriving at new red, green, and blue components that are the average of the colors entered by the user. Remember that the color values are always integers, and division in Python always results in a float. So you want to use floor division when you compute your averages. Pause the video and write the program in idle, or use the code check in the description. How did you do? Here's my solution. I have annotated variables for the 3 components of each color and the 3 components of the result. They're all integers. For the input portion of the program, I obtain the 3 components of the 2 colors to be averaged from the user. An example statement is color1 red equals int input, what is the red component of the first color. I then have the processing code, in which I average the 2 red values, then the 2 green values, then the 2 blue values. An example averaging operation is averaged color red equals open parentheses, color1 red plus color2 red, close parentheses, //2. Order of operations is important here. The division operation has a higher precedence than addition, so I need to put parentheses around the addition, so I'm dividing the sum by 2 and not color2 red by 2, then adding the result to color1 red. That's what would happen if I didn't have the parentheses. I'm using the flooring division //, so I get an integer result with no decimal part. In my output, I'm displaying the colors as red, green, blue triples, and it's quite simple, but there's a lot of interpolation because I'm interpolating all 9 variables into the string. The average of RGB and RGB is RGB. As in the other examples, I've included an f-string version of the output directly below. Now, for my real-world example, I'm blurring an image by hand. This program is called Average Colors Blur, and it's a Pygame program, so you guessed it, you'll need to install Pygame if you want to run this program. When I run it, you can see an image of my channel logo in a window. Every time I click, the image is blurred a little more by averaging all of the pixels around an individual pixel and replacing the color of that pixel with the average. So if there's a white border around a black pixel, the black pixel is going to get a little more white, and the white border is going to get a little more black. The averaging isn't much more complicated than the averaging we did in our program, but the code might not be entirely recognizable because I'm doing the averaging in a loop. That's what the for x in range, for y in range, for I in range, for j in range code is. I'm taking each pixel in the image one at a time and averaging the pixels around it, but I have to be careful. For most pixels, there will be 9 pixels to average, but there could be as few as 4 pixels at the corners. Now, that might sound a little confusing, but once you learn about loops, it will be quite straightforward. Our 3 final programs are similar to the 3 we just wrote, but different enough that I think you'll get some good practice with them. If you got a little stuck on the first 3, hopefully now that you've seen those solutions, these next 3 will make more sense. Program 4, Relative Cost Comparison between bread in Kyiv, Ukraine, and Washington, D.C., U.S. Write a program that obtains the cost of a loaf of bread in Kyiv, Ukraine, and the cost of a loaf of bread in Washington, D.C., the United States. Get both costs in the same currency, such as U.S. dollars. If you consider the cost of bread in the United States to be 1 or 100%, what percentage of that is the cost of a loaf of bread in Ukraine? Another way to look at that is how many Ukrainian loaves of bread can you buy for 1 U.S. loaf of bread? You can see that this program could also be solved using the APIs we used for the original donation program, but we'll just write a console input processing output program. Pause the video and write the program in idle, or use the code check in the description. How did you do? Here's my solution, called Calculate Bread % Solved. For inputs, we obtain the cost of a loaf of bread in each country and convert the user's input to a float. For example, US bread equals float input, how much is a loaf of bread in Washington, D.C. And notice again, I have a $sign in the prompt to remind the user of the currency we're expecting. Although as long as the 2 currencies are the same, it doesn't matter what currency is used for this program. After obtaining both amounts, we calculate the relative percent by dividing the Ukrainian bread price by the US bread price and multiplying the result by 100. When I output this, I interpolate in the result. I'm formatting it to 1 decimal place. And as before, I have an f-string version of the output commented out below. Program 5, Addition with Characters. Write a program that obtains two one-digit integers from the user as strings. The program should convert them to integers using ORed, add them together, and display the correct result to the user. You'll use the same skills for this program that you used to convert a lowercase letter to an uppercase letter. The digit Unicode values are in order, just as the uppercase and lowercase letters are. Don't use int to convert the strings to integers. Use ORed. Pause the video and write the program in idle, or use the code check in the description. How did you do? Here's my solution, called addCharactersSolved.py. I have a constant in this program called digit shift, which is just the ORed of 0. If we subtract the ORed of 0 from the ORed of a numeric character, we'll get the integer value of that character. For example, the ORed of 0 is 48. The ORed of 7 is 55. 55 minus 48 is 7. The ORed of any digit minus the ORed of 0 will be the integer value of that digit. I then annotate variables for the two digits as strings and for the total as an integer. For the input part of the program, I obtain the two-digit strings from the user. I don't convert them. The challenge is to write this program with ORed. I then calculate the total by adding together the ORed of the two digits and subtracting 2 times digit shift, the ORed of 0. That's the same as adding the ORed of digit 1 minus 0 plus the ORed of digit 2 minus 0. I then display the result, and below that, commented out an F-string version of the output. For an extra challenge, try writing a version of this program that allows the user to enter two-digit integers to be added. You can get at each character in a string using indexing. For example, if number is a string with 2 characters, number sub 0 is the first character, and number sub 1 is the second character. Program 6, Brighten a Color. Write a program that obtains the red, green, blue components of a color from the user. The program should brighten the color by adding 50 to each of the RGB components. The RGB value should not go over 255, so warn the user to enter a value between 0 and 205 for each color component. Pause the video and write the program in idle, or use the code check in the description. How did you do? Hopefully this one didn't feel like too much of a challenge. Here's my solution. I've annotated a constant called brighten value and set it to 50. Then annotated int variables for red, green, blue, and brighter red, brighter green, and brighter blue. I obtain the red, green, and blue color components from the user, and then add the brighten value constant to each of them to brighten them, storing the results in the brighter red, brighter green, and brighter blue variables. I then report the brightened result to the user. For an extra challenge on this one, find the smallest difference between each RGB value and 255 and add that difference to each of the color components. You can use the min function to find the smallest difference between RGB values and 255, or the max function to find the largest of the RGB values. For example, if I type in the console min 255 minus 120, 255 minus 200, 255 minus 230, it returns 25, the difference between 255 and 230. So that's the maximum brightening value I could add to my color components and keep them all at or below 255. It adds an extra challenge to the program, but it ensures the results don't go above 255. And I'm sure you can imagine that this brightening math could be applied to an entire image, as we did with the color averaging. I hope you found these examples interesting and helpful, and that you were able to program them yourself. If you found them challenging, try again, and check back with the video if you get stuck. The code solutions for these programs, including the contextual code, is available in my GitHub repository. There's a link in the description. As always, have fun and keep coding.